Welcome DC-ACM members, guests, and our esteemed speakers. We have an outstanding webinar session planned today. I'm Shahnaz Kimberry, the current chair of DC-ACM. Before we begin, we want to take a few moments to share the DC-ACM goal and introduce our leadership team. Our current vice chair and secretary is Catherine McClintock. Treasurer and programs chair is Mike Salera. And our member at large is Amar Zumwala. With over 100,000 members, the ACM is a professional association for computing professionals and students. We are the DC area chapter of the Association of Computing Machinery, and our goal is to create professional development opportunities for our members. We thank our members for joining us today, and we encourage today's visitors to become a part of our growing community. Some of our upcoming events are listed on your screen, and we hope you can join us on all of them. If you're interested in participating in the DC-ACM leadership team or present in our web series, please email scamberry@dcacm.org. If you would like to present on site, please email mike@dcacm.org. Oops, sorry about that. We would like to thank our distinguished speakers tonight and also DeVry University for providing this Adobe Connect environment. It is now our pleasure to introduce Hybrid Cloud Pathways, Blending Games, Immersive Microsimulations, and the Internet of Things, our first presentation in our web speaker series. Our speakers are Dr. Andrew Stricker. Dr. Stricker serves Air University by helping to design, develop, and implement advanced and emerging learning technologies into Air Force educational and professional military education programs. Prior to his arrival to Air University, Dr. Stricker served Vanderbilt University as Associate Provost for Innovation Through Technology. He was responsible for working with academic, technology, and administrative leaders to prioritize, plan, and execute the infusion of educational technologies and enabling innovations for improving learning, teaching, and research. Dr. Stricker also served 27 years as an Air Force officer and scientist, specializing in behavioral sciences and human factors engineering. His graduate work was conducted at Texas A&M University and Yale University. Joining him tonight is Dr. Cynthia Calongne. Dr. Cynthia Calongne, aka Lear Lobo, is a professor, author, game designer, and researcher with 20 years of experience in developing virtual environments and teaching. For 13 years, she works as a software engineer and a systems programmer for Air Force Space Command and on Capitol Hill. In 2010, their Air University team won the first $25,000 grand prize in the Federal Virtual World Challenge for the Mars Expedition Strategy Challenge. During the presentation, please feel free to ask questions. To ask a question of the speaker, simply type your question in the provided chat area in the lower right of your screen. If you are on Twitter, we hope you will join the conversation at #DCACMwebinar @DCACM. Stay in touch with the DC-ACM using social media and our website. Our contact information is located on the screen. We look forward to hearing from you. Dr. Stricker and Calongne, you may now begin your presentation.
Well, great. Well, thank you very much for the wonderful introduction. And on behalf of Cynthia and myself, we are just thrilled to be able to share the work that we're involved with. We have been working on the things that we'll be sharing this evening for several years, actually, in a very collaborative fashion across multiple universities and our colleagues interested in the areas that we're going to be chatting about tonight. As you can see, we're very ambitious to try to link up a lot of interesting components that would span virtual and physical spaces, and we're going to talk about some of the prototyping efforts during this webinar and discuss some of the insights that we've gleaned from the efforts that we've undertaken. As you can see from our intro, I'm sorry, Cynthia, go ahead.
Yeah, I just thought I'd chime in here for a moment. See these two slides here on this slide, the two images of the websites? These are portals to some of the research we're going to be covering here tonight. Andy, back to you.
Well, thank you. Yes, I'm glad you brought that up, Cynthia. That everything that we're sharing tonight, there's additional information and, in many cases, examples that you can actually interact with from the portal site. So that will be made available for you to try out. As you can also see, we're very interested in how to put things in a smaller scale. So we talk about the micro level of our learning simulations, and we want to be able to exchange data across these various micro devices and applications using the Internet of Things, and more recently with our efforts involving Raspberry Pi. So next slide, please. The environment that we're wanting to interconnect and integrate, for lack of a better description, I guess you might say, we've taken to calling it an integrated learning environment, and we believe that these really interesting capabilities are rapidly emerging between physical and virtual spaces. Almost quite a few things in our everyday lives now offer the opportunity to be augmented, as it were, in our physical activities with our devices, and to support the ways that we communicate and problem solve, and give us the means to actually record and have access to tremendous amounts of data. Well, in our cases, for both Cynthia and I, we're very interested in the use of these kinds of bridging environments as it supports learning and instruction. So what we've been doing is building examples of these kinds of integrated environments on the cloud, and providing the opportunity for people to span, as it were, physical and virtual spaces, both formally in curricular degree program structures, as well as informally in things that they might do outside of schoolhouse programs. And we're driven primarily by a very strong desire to provide positive choices for how people can learn, in the ways that you would expect to support adult learners, and make those activities for them highly interactive. So we're very excited about the capabilities involving, for example, model-based reasoning, with ways that you can support that in learning in 3D. Cynthia, thank you. This architecture is evolving, and everything that you see here is pretty much open source. We're excited about the growing capabilities of the open source community. We have found very robust applications, both on the infrastructure and service side, as it's employed in the cloud. We have at this point put almost everything, I believe, in this framework into play, involving the Air Force's Air University. Now, Air University, just a little background quickly, is the place where our airmen receive educational programs throughout their service span in the Air Force. It has our War College and Squadron Officer College and various community degree programs, and we even have doctoral programs. So we cover the full spectrum. So we're wanting to reach out, which we do in all of our programs, that would span the globe, involving well over 300,000 students. So it's huge. So we were drawn to the capabilities of cloud computing to support the scale of what we want to be able to do, involving our formal and informal structures in the Air Force. So that said, we've put into play here, as you can see from the diagram, a portal, and we call it Studio X. And from that portal, we have employed Shibboleth. And Shibboleth gives us a capability to authenticate from our Active Directory service into a number of areas that we want to provide the interconnections with. So, for example, we have employed OpenEdX. OpenEdX has been a tremendous capability for us at Air University. It gives us a way to highly modularize our curriculum, and we've been working with the various founders of OpenEdX from MIT and Harvard and Stanford to employ OpenEdX in a distributive way across our various cloud services. And that is very exciting for us because that enables us to really have some tremendous computational power that would span the globe. And so at this point, we have also embedded in this environment the open source open simulator capability. This is a immersive 3D environment, and there are a number of universities around the country that have pioneered this capability as an open source, and actually involving several of the universities I've already mentioned. We have large, we're going to talk about this later, but we actually have a large footprint now in the metaverse, as it's called, that gives people a way to interconnect and travel, as it were, across these virtual campuses. We also have employed some really exciting new capabilities from the collab, ADL Collabs, involving the Learning Record Store. They have put together the means through the XAPI protocols for moving data in a form that has a taxonomy that can be coded very nicely to store learning data. And that is the basis of our learning analytics that we are collecting across all these parts in the environment. We have dashboards that are in play to make learning visible to both the student and the instructor. And we also have these kinds of dashboards that are integrated into, for example, the usage of OpenEdX. And the Army Game Design Studio is involved in helping us with a lot of the dashboard integration development work. Now, the other exciting part for us has been to leverage a lot of the commercial game engines that we can in ways that would make sense for us to give us a way to bring in some really high fidelity associated with our learning simulations. So you'll see here in the diagram we have Unity game engine that we're employing. We're going to talk about that a little bit here in some of the models that we put into play, but that gives us a way to, micro scale the learning simulation. So we're designing these simulations to take up between 5 and 10 minutes of time by the student. And so basically we want these simulations to hit really challenging concepts and be able to support the what-ifs that we want our students to have experience with in problem solving. We've also employed the Big Blue Button open source for web video conferencing, and that's also connected through learning technology interoperability standards into the OpenEdX. And we have also embedded that into our portal environment. And I won't talk about it much tonight, but just so you know, we've done a lot of locomotion work with this environment. We've integrated virtual spheres and Oculus Rift technologies. We were so very honored recently to be able to demonstrate our first Oculus Rift capability to the leadership of the Air Force. And that has lots of possibilities, as all of you can imagine, with ways that we can increase the sense of immersiveness in the 3D applications that we're developing. Now, you'll see here that there's an informal and formal component. What we've done is we put a lot of social media capabilities into play so that our students and instructors can form their own peer groups and associate outside of our immediate university environment. And we find this very compelling for fostering creative and innovative research and new ideals to basically help us transform in how we think about how we educate. And so we are tremendously excited about what we can do when we effectively give the means for people in a very transparent fashion to go across their informal associations and networks as it informs and supports their formal activities. Cynthia, is there thoughts here that, okay, thank you.
Well,
Now,
I could add a thought or two, but I know we have some really colorful and detailed slides. I think the important thing here is we're talking about on the right, imagine for a moment the traditional classroom, right? And the curricular tracks of leadership, profession of arms, the warfighter, communication, those kinds of things. And then think for a moment the opportunities that video has presented, right? But video is passive. So what we're really thinking here is not just immersive, but interactive. You know, the ability to have these experiences that translate and transform to real life experiences. And we recognize some of the limits of the virtual world, but think of that as our prototyping tool, our interactive communication, where we try to simulate the face-to-face experience and to provide really deep immersion when it comes to activity-based learning. Now, the addition of the Unity 3D, of course, gives us mobility and portability with apps and tablets and other kinds of devices. The Raspberry Pi allows an architecture where these devices can go into the classroom, be segregated, kind of like independent virtual worlds that are unique to that locale, and then can hypergrid and interact with the main campus in the cloud. Andy, we'll move on to the next slide.
Oh, thank you. Thank you. Well, what we've been doing is, as I mentioned previously, is wanting to create these components that can fit into these learning pathways, these learning sim components, and so they would be very modular, and they can operate within the self-selected pathways for learning in Open edX. They can be available outside of the formal structures and be offered on mobile devices. And so we get a lot of leverage when we employ this kind of micro approach. And so as you can see from this diagram, what we've been able to do so far is employ them on mobile devices such as smartphones. As Cynthia mentioned, we've tested them on the Raspberry Pi. We have then a kind of an interesting connectivity for the data to flow. So all the data flows into the cloud, and through multiple database structures, they feed into a learning record store. And from the learning record store, which is really another abstracted layer, database layer, it's able to be used by other applications to pull into dashboards. So we've, for example, have the Mahara open source portfolio that we use for a dashboard component, as well as our Open edX, as I mentioned earlier. Cynthia, any thoughts here that occur to you on
Andy,
the
we had a question from George asking why you used Ubuntu instead of SUSE or Red Hat or one of the other forms of Linux.
Well, we certainly like the no charge factor with Ubuntu, but we use Debian. We use multiple flavors of Linux. Even Raspberry is a flavor of Linux, and so we kind of leverage what the purpose of what we're doing with the operating system on the type of choices that we make, and we find that we get different advantages based on which operating system that has evolved with that open source community and effort. And so we're looking for stability, ease of maintenance, so we can sustain these versions over time. One of the things that we're doing with our open source efforts is being very careful so that at each release we sort of benchmark our efforts with a stable release of an open source capability. And so hopefully that answers your question. Good question.
Sounds great. That's right. I have to admit, I'm using OpenSUSE here at home and another flavor of Unix too. So that just happens. See, I mentioned in the chat, I don't know if, Andy, I'm kind of giving a little commentary there for anyone who might have a hard time hearing or be moving
Right.
outside of access, because that happens in these webinars. But well, one of the things to think of here is, as you're looking at the bottom of this slide, and I know on the bottom left you're seeing the app-based version of Unity 3D, right? In the center, you're seeing a little card that is an aerial look at a virtual world region, right? Some of the content within it. And then he's also superimposed over at a keyboard and some other things to talk about how we interface and interact with these technologies, right? And then, of course, you see the Raspberry Pi in the next little image, and then there's this notion of what happens when learners move into these kinds of environments. What do they do, right? So it opens with a briefing, right, that sets the context, the mission. Imagine the Mission Impossible music going off, dum dum da dum, right? And you get this setting that pulls you into the story, right? And then, of course, you have the game activity, and the game activity can be varied. I remember one of the early games that Andy designed was a hostage rescue game as a part of a game simulation kit. And we call it a kit because we can play lots of different games within this same environment. So we have this notion of reusability and extensibility. And so we're not just leveraging the extensibility and flexibility of the cloud, we're also doing it in the game architectures, right? And then, of course, the debrief scene, because you always have to map back to those learning outcomes and see, well, what did we achieve? Is it meaningful? And will people retain knowledge of this, right? Will this matter over time, right? And so I think that's what's powerful about this, is to see the interaction of open source technology with low cost. And see, that's really kind of powerful, because in the government, you don't always hear of low cost, right? And then it's almost has this maker spirit, right? Of the part of the maker movement, where we see all these low cost technologies like Raspberry Pi, like the cloud, pennies per hour to host this stuff, right? And then this notion of open edX and this opening it up to the world, that's really very powerful. Well, Andy, I'm going to move on to the next slide,
Right.
and we'll talk a little more about it.
Okay. Well, this visual depicts the flow of what we've done with an example template for micro learning simulation. So when you come into the simulation, you register, and from that registration, we're able to then make sure we associate the user activities to the various information that we're keeping in our databases. So we have, like Cynthia highlighted, kind of like a bookend model where a lot of our introductory, preparatory kinds of information, discussions can take place in the intro, pre-scenes, and then they go into a highly interactive scene where it's very engaging. They actually have to do things, get things accomplished, and then they receive a debrief. And from there, we employed some gamification kinds of things with leaderboards and other kinds of things that you can put into learning sims involving some of the competitive nature of time clocks and points that you acquire and so forth. And we find that with our students in the Air Force, they actually really like that. They like that kind of similar experience that they have with their gaming experience outside of the Air Force. And so over the years, we've brought tremendous capability into play, and how we at least get very close to mirror that game experience in our learning activities. One of the things that really intrigues us with this kind of parallel design effort between gamification, applications, and the design of the learning sims, and in the data we're collecting in the ways that we can support the model-based reasoning activities that are very robust ways to gain deeper insights in how people learn, is that by combining that type of data, we get a much better sight picture of issues around motivation, how engaging the student it would be, the levels of what works to improve interactivity. And from everything we know from our research, if you can hit those three areas, if you can increase interactivity, increase the level of engagement, in other words, they're engaged in a very active way, and if you can increase the meaningfulness, then that's a win. That is a very positive benefit for everything that we do with these kinds of technologies. And as I mentioned earlier, is that across this spectrum, we're designing these micro learning sims to be usable across Android, Apple devices, Mac desktops, PC desktops, and just try to give as many options as possible to our population of students and instructors. And we've employed actually these technologies and this integrated learning environment operationally at the start of this year for the first time in our curriculum, and already the survey data coming back from students and faculty is extraordinary. They love the choices and options provided to them. They love the various ways that they can actually learn through these pathways and have access to this kind of learning activity regardless of where they're located, whether they're in the schoolhouse or they're at home or on the job. This has been a huge benefit to our students in the Air Force. Cynthia? Okay, thank you. Well,
Andy,
Cynthia,
all I mentioned was I kind of foreshadowed the Alexa Echo, just to let you know, because you were talking about interfacing with your dashboard, the analytics dashboard. And for those who don't know what I mean, and I'm not talking just about the product, I'm really thinking about an Internet of Things kind of capability where Andy can be sitting on the farm, right? And he can be doing the things he normally does, and he can still interact with his tools, with his portal, and gather some of these analytics. Over to you, Andy.
Oh, thank you. Perfect lead. Well, of course, since we're really excited about open source, we took the Open Source Media Center and we used that on the Raspberry Pi. And so we created basically our version of the Learning Media Center from that open source. And from there, we put them on these micro cards, and we can plug them into the Raspberry Pi to basically, have it reconfigurable on demand for various applications. And so that gives us a lot of capability within the physical classroom spaces to support a range of media services. So we have, for example, these items that we call EduCast. And the EduCast is sort of like an NPR kind of a format, but our instructors prepare them. And so we have our TV station at Air University help us design these broadcasts that we call EduCast, and we play them on our internet radio station for the university, and we also broadcast them in to the Learning Media Center. And this goes also for videos, and we have our instructors prepare like TED Talks, and they are made available. And all this is packaged up in really nice ways, in curricular focused ways on the microcards. And in addition, these kinds of interfaces give you access back out through the internet, and so you can provide some really interesting linkages, between the physical and virtual spaces, and they run wonderfully offline as well as when you have the online connection. So we have a lot of flexibility in how they can be used to support our mission in education. Any other thoughts, Cynthia, that come to your mind on this one?
Well, Andy, I was typing in the chat log, and see, I'm speaking at a conference. They're giving 2 sessions this next week, and we have to always do do an accessibility piece for the hearing impaired. So if anyone's distracted by the chat, my apologies. But look at the positives. You can copy and paste it and save it. But my running commentary has mostly been about how all this stuff comes together to give learners opportunities to learn in so many media-rich ways. I think that's what's of value here. Imagine the old classroom of the past. As we try to move into the future, we're trying to preserve the values and the wonderful strengths of the face-to-face classroom. We're not throwing that away. That still happens. But it's this notion of having this media-rich environment with this cloud infrastructure and these data analytics and all these open source tools that allows our tinkering spirit, right? I think that's what's really critical here is the tinkerer to do some pretty amazing things, integrating all this together. Now, what's really cool about this project, just so you guys know, is that Andy uses a loosely coupled architecture. He'd call it a weak tie network from psychology. But think of it as Barbara, myself, Irving, and a variety of others coming together and cooperating with this project. But we're not working for them, right? We're not co-located. We are researchers who are active and interested in what's going on and helping to shape this future. So that's what makes it really interesting.
Okay,
there
great.
You go, Andy.
Let
me say one thing about this before we get warmed up. When you look at this slide, while Andy explains what's going on here, you see those little symbols at the bottom. Think of those 6 at the top of that, the dragons, the knights, the bulls. Think of those as squadrons with like 100 students each, right? And running perhaps on a Raspberry Pi 2 or some other little device, those micro-learning devices. And think of them as when they want to be connected to the main campus, right? They can connect up and Hypergrid. And Hypergrid is the ability to put in a link and a port number to be able to access the main campus on the cloud. So think of it as the flexibility of the web, but think of it as the 3D web, okay? And if you don't know what I mean by that, think of it in the terms of when you visit a space, you see yourself there and you see others around you in context, okay? And the context you're visiting is a prototype for many of the games that Andy's constructing in Unity 3D. So think of it as we do it in 3D, in mesh or other material there in the virtual world, test it out, understand its interactive behavior, and then he automates all of this in Unity 3D. Over to you, Andy.
Oh, great. Well, I saw in the chat window someone asked about things that we do to help secure data and communications across the interfaces, and DISA gives us great support on the server side for a lot of security tools and safeguards, and we also do a tremendous amounts of encryption and secure socket layer protocols that we use with our mobile apps. And so everything that we do, involves the use of certificates and as best we can. And so far, what we're finding is that with our use of the cloud, it's given us actually some really robust ways to put in play a lot of advanced notification triggers. So if there's any denial of service attacks that occur, we immediately find out about those, and we just love the fact that our virtual machines are layered, and so we have actually robust ways for failovers to occur and almost instantaneously within a few seconds, and we love that part of it. The thing I like to point out, and Cynthia, thank you so much for providing the description of all this, is what we're wanting to do within these really expansive grids, right? These grids are actually virtual miles wide, several miles. As a matter of fact, we have a huge immersive grid that is called X-Base, and we took geospatial maps of the Grand Canyon and we brought it into the 3D environment. It's so large, you can get into a virtual helicopter and fly down into the canyon, along the Colorado River, and we have several base locations that you can travel. And we have a complete airfield in X Base that supports a number of aircraft that you can fly. And so it's just really incredible the kinds of things you can do to represent in really interesting models to support the authenticity of how people can learn in ways that they can see the relevance and the meaningfulness of their activities, and particularly contextualize it in such a way that the transference of skill sets, right, from the learning activities themselves, there's a higher probability they would be successfully transferred into the application of it outside of the educational programs. Next slide, please. We are, like I said earlier, wanting to create a kind of ubiquitous experience for our students and instructors, and part of that has been our excitement with vocal commands and support, adjunct support through devices like the Alexa interface, voice-activated interface of the Echo device from Amazon. So what we've done is we have developed some test cases involving ways for instructors to give rubric information through various activities conducted in the classroom. So they have a way to create through vocal interaction with the Echo device, student rosters and award points for students, and very dynamically query information from the apps that we've used. Now, what we've done with this is we've tied it into the new Lambda services in the Amazon cloud. This is so exciting for us because with Lambda, all of our code that involves the support of these applications are only activated and executed on demand. And so we don't pay for stagnant usage rates as you would typically expect with that arrangement, but we only bring it into play as it's triggered. And so that gives us really an exciting way to minimize cost, and we just like too how efficient it is to only use what you need to use. And so for us, we see a kind of a very interesting future with these kinds of devices that can be put into physical spaces and then interconnected with the cloud.
Hey, Andy, did you see
any thoughts here? Yes.
George's question about dialects for the Alexa? See, George, you can customize the Alexa.
Yes.
Yeah. And then you can also write Java apps for her, right, Andy?
Yeah, so just about anything you can imagine with this software development kit now, you can pretty much do. And particularly if you tie it back to the cloud and all the various services that are offered, and there's a growing community of developers too, by the way. I mean, each month we've seen just exponential growth of people that are actually developing now software applications for the Echo device. So, okay, next one, please. When you look into the capabilities of all this put together, you get a very interesting way to, as I said earlier, modularize the kinds of things that you're going to do in the environment. So if you put in a Raspberry Pi into play and into the learning space, and you support multiple types of learning activities or learning media centers on these micro cards, you get into a really interesting dynamic that supports a lot of creativity. And so we actually have our instructors now in Squadron Officer College that are actually putting together a lot of our early applications, because they're given the tool sets in which they can rapidly put these activities in play. And we find that fairly revolutionary when we don't have to have a deep bench of developers, right? Like you would expect several years ago to take several months to put these kinds of capabilities into play. We actually are finding that with the tool sets that come in to play in what we offer in our cloud portal, they can build these learning activities fairly quickly. Next slide, please.
Andy?
Now, yes.
Before you move into this one, just one thing about this. These pre-imaged little cards you see down here in the lower right, think of them as hosting entire virtual worlds with regions, grids, all the scripts, the interactive objects, all the stuff you need on those things. There you go, Andy.
Oh, yes. Well, when you look at the flow of how all this works, it's pretty interesting. You can actually, as I said, create an environment in which triggers are in place so that if you say something to the Echo device, it can trigger an application to load up. And from that application, it triggers other software code in Lambda to execute. And so you can actually then provide feedback in world to your students on information panels, and you can actually set conditions of the learning sim in the 3D spaces. So it's kind of we're at the frontier early stage of this, but we see a lot of excitement for kind of the ease of use for our instructors to preset up these learning environments, so they would involve some combinations of classroom activities with the learning simulation work. And it's kind of like it's a design studio model, that universities have really been fascinated with, where you go in to the classroom time and you kind of flip it. You might have heard the flipped classroom phenomenon, where you, instead of just didactically lecturing during the class time that you have with your students, you support the active engagement and discovery of deeper levels of understanding that is made possible because you can have your students do things outside of that classroom time to cover a lot of the basic factual information, and then use that time together to do all the things that being together allows you to do. So that's one of the benefits that we see for our Air Force education programs is how these kinds of environments support that much deeper levels of learning that we want to see for our airmen. With the those of you that are interested in the database side of this, we are tremendously excited about the Dynamo database capabilities that Amazon Web Services offers us. We can scale it rapidly to support hundreds of thousands of students and instructors that are interacting with the data flow. We find that with what we can do with that kind of data structure is we can have a distributive model so that different types of data can be moved around depending on the usage in other applications. And what we also find is that through the ways that the cloud offers these access points, depending on your location or on the globe, it speeds up the data transmission tremendously. So we target the geographical areas of where the highest connective rates are to get into our integrated learning environment. So we also use a RESTful API calls that takes out a lot of work to rapidly employ applications. So we repurpose our API calls fairly quickly, and so that helps on development side of the effort. Okay. Well, as you can see, we've been busy, and I just wanted to highlight where we're at with these pieces coming together, particularly on the micro level. We got our initial integrated learning environment up on the cloud running for in a robust way for supporting prototyping in February of last year, and we started intensive beta testing of our early prototypes, and by January, just recently in this year, like I said earlier, we implemented it in an actual college program at Air University. So we actually have several hundreds, actually a couple thousands of students and instructors now using the environment. So we're collecting massive amounts of data. Data that tells us how the overall infrastructure is handling, the large populations, and data, survey data associated with the perceptions of the students and the instructors and the utility and all the things that you would want to collect that kind of data from. And we're expecting to go full operational capability by January of next year. And in between now and then, we're rapidly iterating through, all the different parts that we've highlighted. The thing that I sense is, you'll see in the bar chart there with cloud computing, is we brought cloud computing capabilities up fairly quickly. It's just extraordinary how fast you can implement the combined benefits of certain operating systems and applications that you can put into play with the kinds of services you're wanting to offer your user community. So we were able to bring all that rich, wonderful capability of cloud computing up really quickly. But then we're having now to catch up, as it were, with how we leverage that, right, for learning benefits. And so the blue bars in the visual here represent our efforts then now to really sort of run as close as we can to the evolving capabilities of cloud computing, and really take advantage of new ways. So we're not wanting just to sort of put up old materials and approaches into the cloud. We're really trying to transform what we do in terms of ways that we learn, ways that we instruct, and ways that we discover in our research processes that we wouldn't really be able to do otherwise without these capabilities. So those of you that are interested in staying connected with us after this webinar and want to collaborate and be able to come out and interact with us, we certainly invite you to do so. We have spent several years in collaborative efforts, as I mentioned at the beginning of our session this evening. So we are kindred to working with others across institutions, and we invite anyone that would want to do so to join us. Cynthia, thoughts?
Andy? Yeah, speaking of that, Mikhail had a question. He said, could you please tell a little bit about the development team size? Do you use Agile Methods, right?
Oh, yes. It's sort of like Steve Blank. I don't know if you've heard of him, but he's sort of a guru on lean agile methods associated with innovation, rapid prototyping innovation. efforts that are really transformative. And he's done a lot of work with Department of Defense, and he's also done extraordinary activities with courses through Stanford on the next generation of people coming into computer science. And if you look him up and see some of the kinds of things that he recommends that you try to think about, and that is, certainly try to leverage open source. Your teams need to be very lean. Try to think about what you can do in a parsimonious way. Don't try to be perfect in everything that you set out to do, but get going, get doing. And as you can imagine, for us in the Air Force, we love that. We're hands-on in our culture, and so we bring in practitioners into the mix with our designers and our computer science people, those with those backgrounds, and we rapid iteratively prototype. And so we definitely believe in the benefits of that. We've seen over the past few years with this kind of an approach tremendous benefits and outcomes. It's really it's actually caught on. We're not the only ones in Department of Defense now that are using these kinds of lean team approaches. We have several colleagues across the Army and Navy and other places in the federal government that are doing this as well now.
Hey, Andy. He also asked about Agile Methods, so I was typing a little something in there. I gave a talk, I want to say a couple months ago, about integrating Agile Methods with this kind of process that we're doing here. It's not that we're all Agile black belts or green belts per se, and using a Scrum Master and the formal side of the process, Mikhail, but we're using the spirit of the process. So we're thinking rapid prototyping, constant testing, small, bite-sized chunks that are validated. So we're not thinking of an infrastructure that's so heavy or unwieldy that we can't get things accomplished. So Andy, how many people are coding the Unity 3D games? Why don't you tell them that? And by the way, there's probably like a dozen games, in case you're wondering. There's all different types. Some of them are, of course, in the virtual world. Many of them are in the Unity 3D, etc. Go ahead, Andy.
Oh, one of the things that we do is we have different levels of effort. So with our prototyping, we'll be down to 3 people that will do a rough prototype, and then as we scale from the early iterations of that initial prototype up to huge levels of effort involving, for example, like the Army Game Design Studio out of Huntsville. And so if the learning simulation is going to go beyond the micro level, which we do have some very large simulations, then that kind of staffing is pretty enormous, because as you go into the complexities of animations of avatars and the fidelities of the environment, and if you're going to introduce artificial intelligence, which we do in some of our work, then the staffing level increases pretty significantly. But as you can tell from our talk this evening, we're wanting very much to make sure that we have, along that continuum of effort and scale, entry points at the micro level, so that we can be very influential in supporting ways to enhance learning and instruction with these kinds of simulations that don't require huge amounts of staffing and skill sets, particularly when we employ them as templates, in which they come with a structure, a learning structure that can support a common ground of what instructors are interested in for learning activities. Oh, and also when Cynthia, the question about some of the methodologies, one of the things that Cynthia and I love to talk about, which we do every so often, is design thinking and the employment of what we call design studio methodologies, and how we support the ways to take in diverse perspectives from people across multiple subject matter domains, right? Computer science, psychology, engineering, and so forth, and bring those perspectives together for actionable efforts and ways to really have deep insights to execute in very helpful ways. And so that design thinking, design studio work, we've modeled from Stanford University, so you can go out and look them up too.
Hey, Andy,
okay,
just
questions,
with
I guess.
what you have.
Yes.
If there are any questions, please type them into the chat, or I don't know your protocol if you guys ever use voice or whatever, but let us know. What you see here on screen as we're wrapping up, not just our photo, we're standing there at MIT talking, right? And Barbara was a member of the audience, but we're not camera happy, Andy and I. So so unfortunately, only our photos are there. But you see an example of what Andy has designed. I don't remember if you're using Cheetah there, Andy, or some other tool, which is on the Mac, a 3D mesh creation tool. But that's the Huffman Prairie Red Lion Deep Space Explorer, or that's the name that we used when we did the Mars expedition for it. And when you're standing there, you're a very small avatar, a sim, standing there next to it. And it's really rather breathtaking, some of these. So when you think of virtual worlds, don't think old school and the old 2D flat kind of, cartoony looking stuff. Think very glamorous, very immersive, it pulls you right into the context and it takes your breath away, right? There you go, Andy.
And I saw a question there about how to keep in the loop with the schedule shown in the slide. Just so that each of you know, we would welcome the intensity levels of our efforts, right, in the next several months is high. But as Cynthia can certainly witness to, we are constantly evolving with efforts, and so rest assured, if there's what we've shared this evening, there's variations of what we'll be doing beyond the June timeframe as well. So it's in our nature. We see the work that we do as a navigation more than just a destination. We do believe in the pragmatics of our deliverables for quick turnarounds within 6 months or less. That gives us great credibility with the populations that we serve in Department of Defense. But we also understand that there's considerable, constant change occurring with these capabilities, and so we are continuously evolving in our thinking and our prototyping efforts. So by all means, please join us. There will be plenty for all of us to share and work on together.
That's great, Andy. And Shanaz, we'll turn it back over to you. Thank you, everyone. We're so glad to presented this and shared with you. Bye-bye.
Thank you too. We're very, very honored to be able to present.
Thank you, Dr. Stricker and Dr. Calongne, for this wonderful presentation. Thank you for everyone for participating. At this point, we're going to go ahead and close out the webinar. If you have any further questions, please go ahead and use the contacts on your screen, or of course use Twitter at DCACM. Thank you for coming, and I hope to see you all at our next coming events. Thank you all. Bye, everyone.
Bye-bye.